busy.
All right.
And yes, I'm very interested to see what you are doing, and maybe I have any chance to support you with our knowledge, with our resources, what we have. And yes, that's the reason I participate on the meeting.
That's wonderful. Thank you. So Michael Beeks, retired. I was a senior scientist at IBM Research up through 42 years, working in RF analog mixed signal superconducting research. And we actually, one of our department was about 20 years ago, actually one of our pilot projects actually led to 5G in our work with Siemens. Um, but a lot of our work was internal and also licensing for other companies. And I got involved in this. Oh, Louis here. Um, I got involved in this
Good morning.
program. I was just I was part of a robotics club uh, in the U.S. here, and somebody mentioned that they had a Geiger counter, and I said, "Oh, that's interesting." And then I said to myself, "Well, when was probably the worst time to try to find a Geiger counter or to go shopping for a Geiger counter is when you actually need one." So I just thought, well, this I just found this group and started working with them, and it's been wonderful.
Yeah, Michael contributed a
Thank
lot to
you.
the GPS issues we had and troubleshooting and finding out because Michael already made something with GPS based on the Teensy, and we could use a lot of his experience and his knowledge in our design for the bGeigieZen.
Yeah, we wound up winding having to rewrite the core GPS library, core interface GPS library, because the ones that were available just some of them had bugs, and some of them were just bloatware. They had just too much bloatware. So, okay,
Thank you, Michael. And then
sure.
Jelle or Louis, who wanna go
Yes,
first?
yes. Well, I'm Jelle. I live in the Netherlands, 33 years old, currently in between jobs. I joined Safecast in 2019 as an internship for my studies and have been relatively active since. Though last year I joined the Zen development team again, mainly as like the embedded development software engineer, just building the software for the Zen, like the structure, buttons, screens, stuff
No,
like that.
you much more.
Well,
You made the whole core.
I
You're not to be
I
shy
I
about it.
build a
I
lot.
mean, you're the main person for the software. I mean, it's amazing what you do. I mean, very much appreciate all the work.
Yeah, I'm also responsible for most of the bugs in the software. Uh, there are
We're
there are
fixing
some.
it.
I'm aware of those, but they are not like blockers of like blocking the usage of the Zen itself. So and some features that are still in development, like the log viewer.
Oh yes.
I'm still working on
Talk
that.
about it.
Still working on some small prototypes as well, but no progress yet. Yeah.
But basically, that part we have at least we know where we can send. So that's a
Yeah,
good
yeah,
thing.
that helps. Yeah.
Yeah, that helps. Okay.
Thank you for sharing.
And maybe Louis introduce yourself. So Daniel
Sure.
knows what Louis does.
Okay, so my name is Louis Bertrand, and my background is mostly product development engineering, a little bit of a side trip into IT. I'm glad I'm not there anymore because it's crazy, especially security. And for the last 20 or so years, I was teaching at a uh, what they call a community college, or so basically not a university, but it is post-secondary, so it's more like a technician training, that kind of thing. Um, and but basically software software development, basic programming, electronics, FPGAs, that kind of stuff. I retired in March 2023 and looking for something to do. I've been carrying a bGeigieZen Nano since almost when they first started coming out, just because I thought it was a cool project. The open source, the open everything, the public database, and the events at Fukushima kind of even though I'm half a world away, that still found that very disturbing, and thought I could contribute to the project in my small way. And when I retired, I was looking for something interesting to keep me engaged and keep me busy. And I reached out to Rob to join the Zen development team. So worked on some of the firmware, also worked on some of the GPS stuff, and just generally just helping any way I can. Lately, I've not been very, very active because I'm still teaching part-time at a college in the neighborhood, and the course is not going very well. The material was very poorly developed, and I'm basically having to redevelop it on the fly, and that is taking a lot of time. Hopefully that ends in December, and by the looks of it, it looks like I may not have a course to teach in January, which means I'll have a lot more time. And actually welcome the break. So that's me.
No,
Hello.
you did a lot. You did a lot of beginning.
Thank you
work.
for sharing.
Oh, hold on a second. Louis did a lot of beginning work with the bGeigieZen. I basically took the code from the bGeigieZen Nano, modified it to run on ESP32, and then Louis kind of ported it to N5 Stack. I mean, that is his main start of it, and from there on we could work with it. Yeah, so that's basically it. And shall I introduce myself? Or I think most of the people know, and Daniel, I think, knows too. Well, you want to hear my story?
At our last meeting, you have given me a short introduction of yourself. No, it's fine.
Okay, good. That's so what do you want to talk about today, the topic? So, if somebody want to start?
I have well, not much to share except for my small progress on the log viewer. Like I made the class for the view and the menu, and I have on the SD card a small test file that I'm now sending to the API, like reading it and then streaming it as a file to the API, which doesn't work yet, but it's progress. And then
what is the issue with the file sending? It doesn't receive, or it doesn't?
no, I'm just trying to get the code right,
Okay.
like that it compiles and it makes sense and right space spots. So it's a small prototype at first, so not that much progress on it yet. So it's not working yet. So
Did you try with a curl directly on your computer first to see if that works? Maybe.
no, actually I haven't, because you mentioned that it did work, so
Oh, okay.
I'm just assuming
Just to be
that
sure
it works.
that
Then yeah.
maybe it only works for me.
I can perhaps I assume the API allows the deletion of a file and then you can upload it again.
Yeah, okay.
Yeah, I can just use the same file.
Yeah. It could be
Yeah,
that
I'll
it say
do
that the
that.
file already exists. So then I
Mm.
have to delete it, I think.
Yeah, well, I'll try something.
Okay. If you want us to try something, please let us know, because I really like to get this going. People are already asking for it, because somebody came up and said, "Oh, I have a wonderful idea. Why don't you send it directly?" I said, "We've been thinking about it.
Yes.
Make it much easier."
Yeah, if it works, then we just have to figure out a way to show all the log files on screen and be able to like select them to upload. as well as updating the file name so we can know that it has been sent, etc. That
Okay.
what we discussed a few weeks ago, as well as last year. There is a plan, and it's slowly being executed.
Flow is good. If we're getting that, that's the best. Okay.
I thought the main work that we were going to look into was trying to reverse engineer the black box that is the GPS modules. Um, we're trying to find out why we're losing tracking during flights, right?
Yes.
You said that somebody when the unit just stopped locking at that point. And that's the problem with these U-Blocks modules is that it is a black box. And the other problem is that you can't control the input to the box unless you have an elaborate setup to replicate GPS signals. So we're just working. It's a much more difficult problem to reverse engineer what's going inside there. It's well documented, but also unknown when you don't get the data you think you should be getting. So I
It's the
was
no,
looking at areas about just analyzing the.
it's the no
I was just
way.
saying I was looking at areas of analyzing PVT packets and doing. Go ahead.
No. You first. Sorry, I thought you were finished because you stopped, but it seemed to be your internet is.
Well, I was just saying, just by analyzing a stream of PVT packets coming from the GPS unit, you can look at instantaneous velocity, acceleration, and position, and um, one of the other things, Daniel, that we're trying to figure out is how to improve accuracy, or actually probably to put it a better way, how to know when the GPS is not accurate. And the flags that we get from the packets that we receive from the module don't really indicate when we have spoofing or uh, or blocking happening. And there are times and most times when you're actually tracking radiation, the location is very important.
Mhm. Yeah.
And to know whether or not you have an accurate location or not. So that's kind of summarize. Does that summarize it enough, Louis?
Yeah, I think so. Sorry, Louis, you think so too, Louis?
You're muted.
Yeah, okay, here I am. Yeah, that's a good summary. I think specifically the user we're referring to noticed that his logs stopped working at about 4,000 meters altitude, which is kind of puzzling. Um, the uh, one of one of the things I'm working on is I call it the flight recorder, and it basically logs to the same file, but it adds an extra line at the bottom that is extracting all the other stuff from the nav PVT packet. So 2D position, heading, velocity, um, and so on, as well as some accuracy figures coming from that. I haven't had time to look at them in any detail, but I've just been walking my Zen around, in Toronto and just driving around just to collect enough data to have a look at it and see, basically it's going to be one of those things that um, it's all there. Can I make sense of it? And just just start, just looking at it with a spreadsheet or something simple like that as a first attempt. Um, I th think I just pushed, if I didn't completely misuse Git, I think I just pushed, uh, no, published a branch. Now I guess I will commit the branch. It's called GNSS Flight Recorder. I'll do that either during the meeting or just after, and you guys can have a look at it. It doesn't add much to the code. It just collects extra information that Michael's library pulls out of the packet. Basically taking that packet and splitting it up into fields, which makes it fairly easy to pull out. And that's where it stands. I really haven't much more to contribute, other than complaining again about the black box. It's a well-documented black box. We have lots and lots and lots of information coming from it, but we really don't know what is driving that particular field or that particular group of bits, and how the actual fix computation is affected by the various factors. And that's obviously the secret sauce that uBlocks is going to keep very proprietary.
Mhm.
So that's it.
Do you know if there's, I'm just thinking out of the box, if there's a way to simulate an flight? But that's going to be hard because it's just getting the satellites and then making the positions, but you cannot fake that. Or
Yeah.
What I can offer you when help you this, we have a GPS simulation system. We have a Rohde and Schwarz SMW 200A, what we can simulate nearly every GPS signals what is available from GPS cloners, Baidu, and something, and we can simulate different satellites. We can simulate special positions at the world, and can also do blocking tests. Let's say we simulate a GPS signal, and then also we give him blocking signals and many other things. I'm not the specialist in my team. I have one person, he's absolute specialist for GPS testing, but that's something what I can offer you to do GPS testing and special environment. We can chill this complete and can do complete GPS simulation.
can you also simulate a different altitude? Because that
Yes,
would solve it. So
everything we
basically,
can.
if you have a GPS, you can say that it is in flight mode, and then we can simulate without taking a flight.
Yes, we can simulate everything. I can set you on the top of the Mount Everest. I can set you to Haiti and something, and that's possible. Also, we can
Oh,
say
interesting.
how many satellites he sees. We can run you, maybe you know Nürburgring. It's a racing
Yeah, I
race in
know.
Germany. We can complete simulate a race with 200 300 kilometers around the Nürburgring. It's a complete simulation, but it's possible. Yes, it's easy.
And you think there's a possibility we can use it? Because I think this is being used and people using it, their time is also necessary. So
Yeah.
I don't know how much you can commit in that. Can we, for example, ask you to get in GPS, or maybe Yella can send in GPS to you and you can simulate it there?
Yes,
Yeah.
when you, for example, send a GPS to us, we can make a simulation of, or we can do a testing and can generate test data and can say what we give the system and what he give it out.
Wow, that's wonderful.
I can post here something, post something in the chat here. This is a link to our landing page for the point GNSS simulation and the test system. It's very unique. I think we have worldwide less than 25 of the test systems, and we can provide you some hours, 10 or 20 hours for testing. It's no problem.
Michael, would that help you? I mean, then we have some more idea, or Louis, what do you think? Is that a good idea to let Daniel work on that?
Well, well, it's so the point that would be an incredibly undertaking to try to create figure out what you would want to use that method. How do I say it? It's that would mean undertaking trying to completely reverse engineer the black box that is GPS, and that's an incredibly complex system. There's so much math going on, and I don't know that we would get any. My initial point about having a black box, not being able to control the input. Um, I should have kind of, now that you say, okay, here's the way to control the input, is it still going to be something that we can rinse around? I don't know. Louis, you have any comments on that?
Well, I think
Because especially when combining GPS signals that are happening inside of a processor that, uh,
I'm not sure that we really to
we
do that
lost
much
your
reverse
audio, Louis.
engineering. It'd be more of a case of seeing what the behavior is under those conditions. With well, like first is the obvious problem of what happens at 4,000 meters and above. Second of all, if there's a way of simulating some reflections from an urban canyon, that would be absolutely wonderful. And then we can just see uh, my uh, I think my goal is not so ambitious as reverse engineering the system, because then we'd have to do that with an MTK or MKT, whatever the other makers are. But getting a sense of where we can rely on the position reported and where we can't, and just being able to cut to cut that off and say, here we're confident, here we're not confident.
Mhm.
I think you can get out of the GPS signal something what is called carrier to noise. Get you from your GPS receiver and value back what is calling carrier to noise. That when you get GPS blocking the value carrier to noise, it's will be smaller and smaller and smaller. And when you have a blocking or you get spoofing, then the carrier to noise value will be much more lower, and then
Right.
you can also get back the information it's trustable or not.
Yeah. We already extract that data. So are we using it now? No, we're not using it. But the packet that the NavSat packet tells us what satellites we're connected to and the signal to noise ratio of each of those satellites. But we're not actually using that data right now. It's something that we don't actually record in the log file. But that would be something, and but what we were hoping was the level of that directly translates to a measurement of quality, um, and we're not seeing that propagate out to the PVT packet, which tells us here's your, what is that flag that, Louis?
Oh, that the very last one,
There's a
the
few different
invalid,
indicators that you get on positional.
the very last one in the packet, that bit is, they call it invalid LLH, um, longitude, latitude, and height.
Right,
But
right. But it's
I
not even
really
just
don't
that.
know.
It's also the um, the degree of, what is it? Degree of
Oh,
the
dilution of
DOPs.
precision, the
Yeah, the
DOP.
dilution of precision.
Yeah.
Yeah. So we're not seeing enough correlation between weak satellite signals and dilution to be able to use the indicators that are summarized. The summaries don't seem to be correct. They don't seem to be helping us. And I don't know. I don't think that's going to be solved by creating a test bed with known GPS inputs. I mean, it would help, but it'd be a tremendous undertaking.
Mhm.
I don't know. It kind of depends on. I'm not sure how the GPS simulation would work. Is it like a device that sends out signals of satellites that the GPS module picks up, or is it data that's being sent direct? I don't know. I would assume it sends out radio signals that the GPS module picks up.
It's a radio signal. It's over the air. We have a signal generator. He generates the signals for different GPS signal satellites, and you get it over the air.
Right, but that signal
Yeah.
would then be very clear compared to, let's say, being in an actual airplane at a specific height, and then the module would not pick up a confident signal to say this is a valid GPS log. So when I look at the data logs from the Zen, even at that altitude, there are a few valid lines, and most of them are invalid. That's just because they don't get a valid GPS log. And then sometimes it like suddenly gets a valid one again, and then it logs a valid one, and then 5 seconds later it lost it again, and it's an invalid line.
Right.
So if we simulate the satellites with the signal within a room, then the GPS would probably pick them up fine and just log like they would normally do because they can get a
It
good
will
position.
be do in a shielded room. That's it's a complete anechoic shielded room. What we do this, and
Yeah.
then you have not wrong signal, and the signal it's complete clear. It's a valid signal.
Yes,
Right.
yes,
That's
but
what we
I mean
think.
the signal is so clear because it's within the enclosed room, and there is no noise. So outside in the wild, within an airplane, being at
In the signal generator, we generate also the noise.
oh,
We
okay,
generate the GPS signal, and then we can simulate different noises. We can simulate spoofing. We can simulate everything. We can also simulate a second corrupt satellite that we simulate. You
all
have
right,
5 satellite for the right, and you have 3 satellite for send your corrupt signals.
Right.
That's what we have on
okay.
GPS signalization. This is the absolute cutting the edge on signal generator. What is available? We use this also for let's say for defense testing and for other things.
Yeah.
And
Right.
then it would be very useful to have, let's say, a Nano and the Zen, and maybe another Zen with a different GPS module next to each other in that room, all logging, and then like switching the parameters, adding noise, adding cropped satellites, whatnot, and see how it impacts different devices with their different
Yes, and then
modules.
compare the both models. Yes, that's an idea.
Yeah.
What is possible?
Because I think Jelle was referring to that the flights for the bGeigieZen Nano, they work correctly. There's no issue
Yes.
with that. But the flight for the bGeigieZen, it has a different GPS module. The first flight, we only had one at the moment, was corrupt, and the taking off and the landing was fine. So we don't know what happened in the flight.
Yeah. I'd like to see that log actually. The
It's in the
PVT
file.
log.
I think
Yeah,
I
me too.
posted it.
Oh, the PVT log. Oh, yeah, no,
Oh,
we
the
only have
PVT. No,
the nano log or the
I can ask for the nano.
bGeigieZen
I
log.
think I have the nano log too. I have both
Yeah,
of them.
we
No,
have the bGeigieZen logs, but not the
yeah.
satellite
I want
log.
the Zen. I'd like to see the Zen log to see what it thinks it's seeing as well. The PVT file. Do you have a PVT log from the Zen?
No, we only have
Yes
From the
or no?
test
from
bed.
the SD card file. That doesn't tell you so much, I think.
The test bed was not
Oh,
being run. It's just the Zen, like the bGeigieZen running. It doesn't log the
it doesn't log PVT packets?
No.
no.
No,
Okay.
that's what I'm doing with this flight recorder is adding the
Right.
extra line to the log file. There's only one log file the journal file, I think, correct me if I'm wrong, Jelle, but you start off with a journal file that has a temporary name, and then when you start logging it, and get reliable date and time from the satellites, then it gets turned into an official log, but it's always the one
Yeah.
file. So that's
The journal is one file. Like if you turn it off and on again, then it generates a new file.
right. But the point is that there's only ever one file being written to. And that's why
Right.
I've added that second line rather than figuring out how to have a second log file.
You
Or
can make a second log file. That's
okay, well,
I mean,
maybe we
uh,
work on that.
it's not like impossible. I mean,
Okay.
we can do it within
No,
the current structures.
the test bed does it. The test bed records two different, multiple log files at the same time.
Right.
Yep. We could just add another handler which does different
Right.
things than the log.
So
What was it? SD logger.
I'd be interested in doing that with Yella's help. When I have a bit more time, I have to get rid of this course.
Yeah, no problem.
right.
Michael, you want to say something?
We're just saying, think about the goals here of trying to resolve the issues of GPS accuracy. We're not going to be able to fix the modules or the algorithm inside of the GPS modules, but the discovery of having a GPS module that doesn't work at 4,000 meters, that's an issue. Whether or not there are settings, there are default settings that are affecting that, that's also something that we've been looking at. I haven't seen anything that tells us that this GPS module shouldn't work at any altitude. So I don't know. Yeah.
Well, we only have a sample size of one right now, that one
Yes.
log file. So
Yeah.
Let's
I mean, it's a concern.
maybe wait till we have a little bit more because
Yeah.
next week we will have more flight data. So the
Mhm.
2 cents are going to fly from, I think, from Fred to somewhere in America, I think. So let's first see. Maybe this is only a one-off. I hope so.
Yeah. But now you said, Rob, that he has two Zens with him.
Yeah, 2 cents he has.
Could we have one of the Zens running the test bed concurrently with the
Good idea. Yes,
yeah,
I
like
can ask. Because he has maybe 3 or 4 different devices with him when he flies. So
yeah.
So that's a good idea.
So Daniel, the test bed is a separate set of software that has to be loaded. It has to be you load onto your Zen, and all it does is different types of GPS analysis and logging, and also you can use it to set up the GPS unit. But it's a completely separate app that runs by itself, and so it's standalone. So you guys, that one of the Zens would have to be dedicated to that.
Yeah.
Okay.
as long as they had the
we
same
should do
GPS
that.
module, I think that would be valid.
Yeah, I think that's a very good idea. I like that. It's a simple
Right.
approach and not much work to be done. And let me communicate with the person that's going to fly, and I hope he will do that. I think he's willing to do those things. I think.
Yeah, and we can
good.
do a bit of coaching over Zoom or whatever to make sure he's got the thing configured correctly. So if you're not familiar with, like with the idea behind the user interface, it's easy to get it wrong. I've done it. I thought I was logging in. It's like, nope, it's wrong. Like,
Yeah.
Michael, do you
Yeah.
have a very short user manual for the software? So, for example, start and you go in this mode. I do not recall I've seen that. very simple. This
No,
manual.
I did not create something. I can
We're
do
just
that.
about out of time, by
Yeah.
the way.
Okay. Oh yeah, we have about a minute.
Yeah.
Michael, maybe very easy to do is ask Chat GPT to do that. I mean, it saves you so much work. So just let it go through the code and ask it to make a user manual of it. I mean, I've done it for the other things too, and it works so easy. Try it.
Okay. All right.
Give
I'll
it
give
a
it a
try.
try. Not so happy. Yeah.
I know. I can
Oh, Daniel, we're
I'm not a
almost
fan
out of
either.
we're almost out of time. Daniel, I misspoke. Yeah. Daniel, I misspoke. I worked with Ericsson on 5G in the 1990s.
Okay.
We were actually created a beamforming design that a friend of mine prototyped, and then Ericsson and our team went through that to create the first prototypes. Great. It was a great it was one of the best projects I worked on in that 42 years. So we're almost out of time.
We have about
We can
25 seconds left.
continue if we have more to discuss. We can start a new call.
Up to you guys.
I
I'm
don't think
done.
so. I'll also, Daniel, I'll point you to the test bed that we have. Yeah,
Okay.
Daniel, I'll point you to our GPS test bed so you have an idea of what it does.
Okay.
Uses the same hardware as the Zen.